Hi, my name is Justine Harkness, and in this video, we'll look at how to calculate the strength of an electric field between the two plates of a capacitor. Whenever a capacitor is charged, we will have positive charge accumulated on one plate and negative charge accumulated on the other plate. This capacitor will have its own voltage, but because we have a separation of charge, we will also have an electric field. So recall that field lines will always point away from positive charges and will point towards negative charges. So here, if we just connect these lines, we will have field lines for our electric field pointing from the positive plate towards our negative plate. And we can calculate the strength of this electric field using this equation. E is equal to voltage over the distance. Now this is a formula you may have seen in other videos, specifically the last video of the voltage lesson. We know from our electrostatics formulas that the voltage is equal to a constant times the charge over a radius, and that the electric field is equal to constant times the charge over the radius squared. So if we look at the relationship between voltage and electric field, in order to go from voltage to electric field, we have to multiply by 1 over the radius. And that's exactly what this equation says. E is equal to the voltage over the radius, or the voltage over the distance between our two plates. So the D that we're measuring here is our distance between the two plates. And this is always measured in meters. So now let's take a look at some practice questions. So here we are given that the voltage across two parallel conducting plates is 10 volts. And the first question asks us for the magnitude of our electric field if the plates are 0.1 millimeters apart. So we're going to use that equation. Electric field is equal to voltage over the distance. And remember, the distance has to be measured in meters. So if we are 0.1 millimeters apart, that means that we are 1 times 10 to the negative 4 meters apart. At this point, we can just plug in our values into our equation. So we'd have our voltage of 10 volts divided by 1 times 10 to the negative 4 meters. And crunching the numbers, this would give us an electric field of 100,000 newtons per coulomb. And the direction of this electric field would be always pointing from the positively charged plate to the negatively charged plate. Our second part asks us how the electric field would change if our distance was changed to 0.5 millimeters. And this is where we can examine the relationship between our variables in this equation. Notice that the electric field is inversely proportional to the distance. So if I were to multiply this distance by a particular number, that would change the electric field by 1 over that number. So if I were to go from 0.1 millimeters to 0.5 millimeters, that will give me 5 times the distance, which means that my electric field is going to be 1/5 of its original value. So here, if I had 100,000 newtons per coulomb, the new electric field magnitude would be that 100,000 divided by 5, or 20,000 newtons per coulomb. So now you should feel more comfortable calculating the magnitude of the electric field between the two plates of a capacitor.